Okay, the following is a video over 2-7 notes, and this is about proving segment relationships. So we are continuing our study with proofs. We'll be spending a lot of time going over proofs and how we write them and all that kind of stuff. So the first few problems is really about just given a statement, what property of equality or property of congruence or postulate are we using to make this statement? Okay, so you probably want to use all the definitions from chapter 1, so you'll need the definitions from chapter 1, and then you'll need all of the properties of equality. That's from section 2.6, okay? So you'll need those at hand when you're doing these. Memorizing these is a little bit tough, but let's go ahead and take a look at them. The first one says that segment QA is equal to segment QA. Okay, and I've got something that's equal to itself. That one we call the reflexive property. Okay, reflexive property. All right. Number 2 states that if AB is congruent to BC and BC is congruent to CE, then AB is congruent to CE. So this is the transitive property. Okay, transitive property. And if you think about the definition of that, that was when it said A is equal to B and B is equal to C, then A is equal to C. Okay, so that follows the same thing. Basically what I remember is if these two middle things are the same, then you can make the statement of congruence with these two things. All right. So then it says if Q is between P and R, then PR is equal to PQ plus QR. All right, and this is the segment addition postulate. So segment addition postulate. And so what I've got here, one way to think about this is to actually just draw a picture. And this is something that you guys are going to see all the time. And if I had, say, Q is between P and R, all right, here's R, Q is somewhere here in the middle. So if I took PQ, this segment length, plus QR, that segment length, it would give me the entire thing, PR, okay? And so then, let's take a look at number 4. It says, if AB plus BC is equal to EF plus FG, and AB plus BC is equal to AC, then EF plus FG is equal to AC. Okay, this is substitution. Substitution. Okay, and what it says here, it tells me that AB and BC is equal to AC. And so what they've done is they've taken AC and they've plugged it into this whole quantity here and made the statement that if I take EF plus FG, I get the length of AC. Okay, so that's substitution. So these are kind of tricky. They're not the easiest things in the world. You have to really go through and practice this stuff in order to kind of get your footing with this. But let's go ahead and take a look at a proof, kind of show you what I'm talking about, how we go through them and what we want to do. And what it says here, you have these given statements, okay? You're given that SU is congruent to LR, okay? So let me do this. I know that SU, this whole thing, is congruent to LR, all right? And we know that TU is congruent to LN. So TU is congruent to LN. This is a very standard proof dealing with segment relationships. And what I want to do is I start here. Okay, the given part is where you start. The prove part is where you end. And we want to fill out all of the logic that goes in between. So here's my given statement. All right, Merry Christmas, Happy New Year, Happy Kwanzaa, Happy Hanukkah. Okay, and then our ending statement is here. Okay, now we don't write ending statement down here. We've got to have some sort of actual like property, reason why we got there. And so here's what we've got. Okay, we know that these two segments are congruent. we know that SU and LR are congruent. Okay, we know that this distance here is the same as this distance here. And we want to prove, okay, what we want to prove, and we'll put that in red, is that these two segments are congruent. Okay, so what I know, okay, based off of this, is that I can go here, I can start my proof, and I can say, okay, if SU is congruent to LR and TU is congruent to LN, then the next statement says the definition of congruent segments. And the definition of congruent segments means that the segments have the same measure. So the same measure. All right, that's not part of my reason. I'm just trying to explain what the definition of congruent segments are. So I can say this. I can say that SU is equal to LR. Okay, and then I can say that TU is equal to LN. Okay, so I can make those claims that those things are equal, and I can set up these equations. Okay, so I've got, then it says this, that SU is equal to ST plus TU. So if I take these two little segments and add them together and get the big one, and that's the same thing happening here, that LR, the whole segment, is equivalent to me saying the little segment LN plus the big segment NR. Okay, and that's the segment addition postulate. Okay, and that's what we know. Okay, if I'm given this picture, we can conclude this. All right, and then it does this, and then it says that ST plus TU is equal to LN plus NR. Now here's the deal, guys. I know that these two things are congruent to each other. SU is equal to LR. Okay, and so um, I can take these values and substitute them into this equation. So I can take ST and TU, plug them in here, and I can take LN and NR and plug them into here. And so what that allows me to do is I can substitute and I can set up another equation. Okay, and it just says that ST plus TU is equivalent to me saying LN plus NR. Okay, and this is by substitution. Okay, and then part E, we've got ST plus LN is equal to LN plus NR. Now here's what we know. LN is congruent to TU. Okay, so what I've done is I've taken TU and I've replaced it with LN. And when I replace something, that's just me doing substitution again. So substitution. Okay, now what I do is on this step, it looks like I'm subtracting ln from both sides, okay? So the ln's will go away, ln's will go away, and this is the subtraction property, all right? So the subtraction property of equality, okay? And then we get the statement that st is equal to nr, okay? And that's substitution, so it's just, and we've talked about this, how when they use substitution property, that's the same thing as you basically saying simplify. Okay, those kind of go hand in hand. And then because these lengths are equal, we can say that the segments are congruent. So this is just the definition of congruent segments. Okay, so I know it's kind of long and drawn out. This might be very, very confusing to you. We're going to do a lot of practice with this, but this is the basic idea. Okay, and so then let's take a look at number 6. Okay, and it says that segment AB is congruent to segment CD. So this is where I start. All right, so I'm going to go ahead and put that in my first statement, and that's segment AB is congruent to segment CD, and that's given to us. All right, and then it says that their lengths are equal. Okay, that's the definition of congruent segments. Okay. All right, and then all it's done from this step to this step is that these two things have switched sides along the equal sign. Okay, and when I switch the sides or switch things across the equal sign, all I'm doing is what's called the symmetric property. Okay, and that's found in 2.6, that definition 2.6. That's the one where it says if A is equal to B, then B is equal to C, or B is equal to A. Okay, when you switch things around, that's a symmetric property. So then if their lengths are equal, then I can say that the segments are congruent. So CD is congruent to segment AB. Okay, and that's it. Okay, so basically you have a given statement, you have a proof statement, and you want to figure out the logic to go through to get there. Okay, so I hope this was helpful to you. Hopefully you can get started on the homework, and we'll see you soon. Thanks. Thanks.